In this video, we're going to have a look at calculating gradients. So the aim of the video is by the end that you will be able to calculate the gradient of a linear relationship, either using a set of coordinates or from a graph. So when we are looking at straight line graphs or linear graphs, we use the formula y equals mx plus c, where the gradient is m, and it is the slope of the line, and c is the y-intercept. So in this video, we're going to be focusing on the gradient of the line and being able to identify and calculate what that gradient is going to be. So the gradient measures the steepness of a line or a plane. Now, to calculate the gradient, we use the formula rise over run, or we use the formula y2 minus y1 plus x2 minus x1. And those two formulas that you would have seen before are linked. So the rise is the y2 minus y1 value. So the rise up the y-axis as to how far up the y-axis it is going. Run is equivalent to x2 minus x1. So how far along the x-axis does it run? So let's have a look at some different types of gradients. And there's going to be 4 different types of gradients that we can have a look at. The first one is when we have the line that is going up across the Cartesian plane. That is going to be a positive gradient. And if our gradient is positive, then the gradient will be a positive number. The second type is when we have a line and it is going down when we're looking across the Cartesian plane. That gradient is going to be negative, and the gradient value will be a negative number. They're the 2 most common types of gradients. We've also got a line that is a straight horizontal line, and that is going to have a gradient of 0, or a line that is going to be a straight vertical line, and that gradient is going to be undefined. So they are the 4 key types of gradients, with the main ones being positive and negative. So now we'll have a look at how do we calculate a gradient using the formulas from the previous slide in the video. So in example 1, we have a series of equations, and we want to be able to identify the gradient and the y-intercept in both of those. So having a look at A, y equals 5x plus 2, and I want to calculate the gradient and the y-intercept. So the gradient is going to be the value in front of the x. So in the first example, it is going to be 5. So my gradient is 5. My y-intercept is going to be plus 2. For B, I've got y equals x over 2 minus 3. So having a look for the gradient is going to be the number in front of the y, in front of the x, and in this case, it is divided by 2. And in front of the x, I'm going to have a little 1. So my gradient is going to be 1 over 2, and my y-intercept is going to be negative 3, because in my formula, it is subtract 3, and I need to make sure that I look at the value or the sign in front of the number. So in this case, my y-intercept is negative 3. Having got C, y equals negative 2x plus 4. My gradient is going to be, again, the value in front of x, so negative 2. So gradient of negative 2, y-intercept of 4. So looking at D, the formula we are provided is 2y equals 4x plus 3. Now before I can identify the gradient and the y-intercept from the equation, I need to put it into the standard form of y equals mx plus 3 plus c. So I want to rearrange it to get y by itself. So at the moment, I am multiplying y by 2. So the opposite of multiplying y by 2 is to divide it by 2. So divide both sides by 2. So y is going to equal 4x plus 3 divided by 2. And I can simplify that answer. So 4x over 2 plus 3 over 2. And 4x divided by 2 is going to equal to 2x. So my formula is going to be 2x plus 3 over 2. So now that I've got it in that standard form of y equals mx plus c, I can go ahead and identify the gradient and identify the y-intercept. So my gradient is going to be 2, and my y-intercept is going to be 3 over 2, which is equal to 1.5. So that's an example of needing to rearrange the equation first before I can identify the gradient and the y-intercept from that standard form of y equals mx plus c. So let's have a look at another example where, again, the equation that I'm giving is not in the standard format. So I am given 3y minus 4x equals 12. So I need to rearrange it to get y by itself. So first, I'm going to remove the minus 4x. Opposite of minus 4x is plus 4x. So I'm going to plus 4x onto both sides. So that leaves me with 3y is equal to 4x plus 12. Now I need to remove the multiply by 3. Opposite of multiplying by 3 is going to be divide by 3. So divide by 3 onto both sides. Y is going to equal to 4x plus 12 divided by 3. I can simplify that further. So y is going to equal to 4x over 3 plus 12 over 3, which equals 4x over 3 plus 4, because I can divide 12 by 3 to get 4. So now that I've got it in my standard form, I can go ahead and identify the gradient and the y-intercept. The gradient is going to be the number in front of x. So here it is going to be 4 over 3, and my y-intercept is equal to 4. So let's have a look at calculate an example now of how do we calculate the gradient if we don't have the equation, but we've got a graph we can calculate it from. So example 2, we want to determine the values of the gradients for the following graphs. So the first step is going to be identify 2 points and label those 2 points, x1, y1, x2, y2. Now I can choose any 2 points that fall along the line. What I am going to aim for though is to identify a point that I can easily see the coordinates for. So identify a point that crosses over with the grids. And sometimes the easiest way to do that is to look for your 2 intercepts. So I have identified my 2 points. My first one is going to be -3 and 0. My second one is 0 and 4. And I want to label those x1, y1, x2, y2. Labeling them is very important because it means that from here, we've just got to write the formula and then substitute in our values. If we don't label them, then people often get confused and substitute in the incorrect values. So labeling them will help you make sure you're substituting in the right values into your formula. So the next step is going to be to write the formula. So m equals y2 minus y1 over x2 minus x1. Step 3 is going to be to substitute in the values. So looking at my coordinates that I identified, y2 minus y1 is going to be 4 minus 0. And then x2 minus x1 is going to be 0 minus -3. So now that I've substituted in, I can calculate my answer. So 4 minus 0 is 4. 0 minus -3 is equal to 3. So my gradient of my line is going to be 4 over 3. So having a look at a second example, applying the same steps, my first step is going to be identify 2 points and label them. So I need to identify 2 points, and again I'm going to identify my 2 intercepts because they're going to be the easiest to identify, making sure that they cross over with the grids below. So identify my 2 points, 0, 4, and 5 and 0, and I want to label them x1, y1, x2, y2. So step 2 is going to be to write the formula. So m equals y2 minus y1, x2 minus x1. So the third step is going to be substitute in my values. So my gradient is going to equal 0 minus 4 over 5 minus 0. So my last step to calculate the answer it is going to be 0 minus 4, which is negative 4 over 5. So the gradient of my line is negative 4 over 5. And I can do a check with my types of gradient. I can see that my line from the graph is sloping down across the Cartesian plane. So I know that it is going to have a negative gradient. So my answer being a negative makes sense. So the gradient is going to be negative 4 over 5. So I can also calculate the gradient if I don't have a graph, but I'm already provided with my 2 points along my line. And to calculate the gradient, if I've got 2 points, the steps are going to be the same. The first step was to identify 2 points and label them. Well, we've been provided with the 2 points, but I can still go ahead and label them x1, y1, x2, y2. And then second step is to write the formula. So gradient equals y2 minus y1 divided by x2 minus x1. Third step, substitute in the values. So y2 minus y1 is going to be 9 subtract 6. And then x2 minus x1, so 5 subtract 4. So the last step is to calculate the answer. So 9 minus 6 is equal to 3. 5 subtract 4 is equal to 1. So my gradient is going to be 3 over 1, which can be simplified to 3. So having a look at B, again following the same steps, I've got my 2 points, so 2, negative 1, 0 and 5. I need to go ahead and label them x1, y1, x2, y2. Second step is to write the formula. So gradient equals y2 minus y1 divided by x2 minus x1. Substitute in my values. So 5 minus negative 1 over 0 minus 2. And then finally, I've got to calculate my answer. So 5 minus negative 1 is going to equal 6. 0 minus 2 is negative 2. So 6 divided by negative 2 is equal to negative 3. So my gradient is equal to negative 3, and it will be a negative line sloping down across the Cartesian plane. And finally for C, starting off with identifying my 2 points and labeling them. So 0.5 and 1.5, and then negative 0.2 and 1.8. So labeling them x1, y1, x2, y2. Second step, writing the formula. So gradient equals y2 minus y1 over x2 minus x1. Substituting in the values. So 1.8 minus 1.5 over negative 0.2 minus 0.5. So the last step, calculating the answer, 1.8 minus 1.5 is equal to 0.3. And that's going to be over negative 0.2 minus 0.5, which is negative 0.7. So my gradient is going to simplify to negative 3 over 7. So the gradient of C is going to be negative 3/7. So that's some examples of how do we calculate the gradient from the formula, from a graph, or from 2 points.